Okay, last packet is a review packet from the whole unit, the linear function unit. So I did all the answers. The intent here is you should have done them before. You're not just copying or looking, at the answers. Just this is to check your answers. Okay. First page. A lot of these questions are from the state tests, sample questions, so you should make yourself familiar with them. It would be wise. Okay. The table below is the cost of different number of goldfish at a pet store. The cost is a linear function of number of goldfish, which statement describes the rate of change of this function. So basically, rate of change is what is the slope. So I do the change of y over the change in x, I get 30 cents each. Real easy. Letter A. The cost of each fish is 30 cents each. Okay? Number 2. The 4 tables below show the relationship in which x values represents inputs and the y's are the corresponding outputs. All right? Which table represents a relationship that is not a function? You might want to underline that when you see a question like that. What is not a function? Because that can get tricky. Remember, the easiest thing to notice right away is if you have a repeat number in the x column, that is the not a function. Okay? That is not a function. You cannot have the x repeat. So the table T. Moving on. Number 3, up top here. Madison created 2 functions. For function A, the value is y is 2 less than 4 times the value of x. So on the side here, I wrote out, okay, function A will be y is 2 less than, so I'm taking 2 away from something, 2 less than 4 times the value of x. So 4x minus 2, okay? Function B is in a table. In comparing the rates of change, which statement about function A and B is true? So I have to get the rate of change of each. Rate of change in the equation is easy. It's your slope. It's m. It's 4. To determine it here, the change in y over the change in x. So I just divide 4 divided by 2, and I get 2. So my best answer is that it is function A has a greater rate of change than function B. Okay? Number 4, the table below represents a linear function. All right, so they're telling us it is linear, so therefore it has to have that nice pattern. All right, increases by 4 in the y and increased by 2 in the x. So change in y over change in x, I get 2. Okay, which function has a greater slope and a greater y-intercept than the linear function represented in the table? So the table's linear function is simply 2. So I need to compare the linear functions of the choices and look for the greater rate of change. And in this case, the greater rate of change is B. And greater rate of change and a greater y-intercept, sorry. So you needed to find the y-intercept as well, and I was able to determine the y-intercept to be 7. Okay, so if you went backwards, you would get to the 0 or solve for B to get your 7, and therefore the y-intercept is 7. So the equation, we're comparing this equation to those over here. Okay? Next page, if I can turn the page. All right, so number 5. Number 5. A bicycle club went on a 6-hour ride. The graph below shows the relationship between the number of hours spent on the trails and the number of miles traveled. Always take a look at your x and y axis. Generally, the time is on the x, distance in this case is on the y. Okay, so it's not they're climbing trails like mountain trails. They're on a bike ride that, in 1 hour's time they went 10 miles. In 2 hours' time they went 20, and it kept increasing. Okay, in 3 hours' time is 30 miles, so on, so on, so on, so on. Okay, which statement best interprets information about the graph? The flat line here meant that between hour 3 and hour 4, did they increase in miles? No, it stayed at like 34 or so. So if you read all your choices, the best answer is the club members rested during their ride at some point. Okay? Number 6. Which phase describes a non-linear function? This one's a little tricky, so I kind of went through each choice. The area of a circle as a function of the radius. Well, area of a circle is pi r squared right away. Because you have a square in it, it's non-linear. All right? The perimeter would not be squared whatsoever, and the perimeter, of course, would increase as the side lengths increase. The cost of gasoline is a function of the gallons purchased. Yes, the cost is going to be more based on how many gallons you purchase. It's not squared or exponential. It would definitely be linear. The distance traveled by a car traveling at a constant speed as a function of time. So as time increased, more distance is covered. All of those would be a linear example. This, because it has an x square or a square part of it, the area, it's nonlinear. Okay, on to page 4. Which equation represents the line shown on the coordinate grid below? Okay, so first off, very first thing you notice right away, the b has to be -2. So I go down to my choices and go, okay, my b has to be -2. That eliminates this guy and eliminates this guy. So now I have to choose between these two. And I don't even have to think that much harder. The slope here is a positive 2/5. Slope here is a negative. This line is going uphill. So it has to be A. Okay? Which equation represents a linear function? Okay, if you divide by x and x happens to be 0, it is not linear. Okay, it's undefined. You can't have it. Squared, this is quadratic. This is some radical form, never even done one of those. So these three are not linear. The last one, there's your slope, there's your y-intercept. This is linear. Letter D. Moving on to page 5. Okay, number 9. Which graph represents a function? Okay, going back to the beginning of the unit, imagine you have a vertical line test. Place a pencil and you're going to run it across the pictures of each one. If it hits it in 2 places at once, it is not a function. Okay, so like this one would hit in the top and bottom of the box where I kind of scribbled on it, not a function. This one, the straight line, the part of this is straight up and down. The line would be touching it in multiple places, therefore not a function. Same with this one, this little segment here being straight up and down, it has more than one point on the x-axis right here. It would be not a function. The only one is this one. As strange as it kind of looks, if you scan this, that's the one that works. Okay, number 10. Annette plans to visit an amusement park where she must pay for admission and purchase tickets to go on rides. So the rides are going to be variable. The purchase of the ticket is going to be one time. Annette wants to find the total cost for the day for the amusement park. She wrote this equation, $1.50 per x plus 12 to predict her cost for the day at the amusement park. What could the number 12 represent in Annette's equation? So that's constant. It is what we would call the b, or the initial value. It is the y-intercept. So it's the one-time shot pay admission would be the admission. Okay? On to page 6. Okay. Does this equation define a linear function? Well, we can't divide by, so that's right, when x is not 0. This is not linear. You can't have that kind of arrangement. It would be undefined. Let's go through. Continuation of the review. Okay. So this page, multiple choice. Choose the letter. Best answers. What is the equation on the line that passes through 0.5, 8 and has the y-intercept of -2? Well, all of them have the y-intercept of -2. The next step is to put this 5 and 8 in the equations and see which one works. Just so happen right away, put the 8 here, because that's the y, equals 2 times 5 minus 2. 2 times 5 is 10, minus 2 makes 8. That's the one that works. I showed one that did not work. If you put 8 here and 5/2 times 5, this gets you a whole decimal. It's just, right away you say to yourself, no, not heading, it's not going to make 8. Okay, and the other two I didn't even bother trying. If I put it here, let's do some mental math. 6 times x, 6 times 5 would be 30. Minus 2 is not making 8. Okay. Number 2, which table does not show the patterns of a linear relationship? Remember, for it to be linear, we have to have a constant rate of change. Some of them can be a little bit tricky. You have to watch. So if I go to this one, I went from 5 to negative 5 was minus 10. But then from negative 5 to negative 13 was minus 8. Then from this one from minus 8. But if I put them as a fraction, change in y over change in x, so negative 10 over positive 5, okay, if you look at the changes between these two, negative 10 over positive 5 makes a negative 2. If I do the same here, negative 8 over positive 4 makes negative 2. So technically the rate of change here is linear because it's constant going by the slope is negative 2. Okay? Whereas this one, negative 3 to negative 1, 1 thing. Okay, all of these, this side was plus 2. So far that looks good. So if this is all plus 2, then whatever the value is over here, it has to be the same. Instead, it went plus 2, plus 1, plus 3. Bam, nonlinear. Okay, let's just look at this one. So on this one, we went from negative 2 to 1, right? And then from negative 1 to 0, so these are all what? Plus 1, plus 1, plus 1. So it's constant. If this side is constant, it works. 3, 3, 3 works. This one, last one. Negative 2, so on my x column, what did it do? How did we count by? By plus 2, by plus 2, by plus 2. So if this is constant, and if this side is constant as well, it will work. 10, 20, 30, 40. There you go. So linear. So the only one that's nonlinear is letter B. Definite type question you will see on both the algebra readings and the 8th grade test. Number 3, the gas tank in a car holds a total of 16 gallons of gas. The car travels 75 miles on 4 gallons of gas. So we know in the sort of the unit rate you can figure out here is 4 gallons will take 75 miles to use up the 4 gallons. If the gas tank is full at the beginning of the trip, which graph represents the rate of change for this particular car? Okay, so the gas tank is full, and what we were saying is a total of 16 gallons. So when we look at our graph, we need to start at 16 and then do what? Have it deplete or go down as miles went by. So this is starting at 16, and at 120 it was 0. Could be. Let's think about this one. Did it start at 16, and then why is the line going backwards? So that's not happening. So we'll keep this one in mind. This one starts at 16, and at 300 it is depleted or down to 0. The gas at 300 miles is done. Over here, this one started at 0. Well, no, we know the gas tank started at 16. So these two are eliminated. Now we got to decide between these two. So did it empty out at 120 miles, or did it empty out at 300 miles? So take a look. I found the unit rate is 75 divided by 4 comes out to be 1875. So 1875 miles per gallon. How many gallons we have? 16 gallons. So 1875 times 16 is 300 miles. So it would be empty at 300 miles, not at 120. Okay? Think. It's not so hard. You usually always can eliminate 2 of them. Okay. Which diagram represents a function? Again, the vertical line test. If it hits it twice as you scan across with your pencil or whatever it is, then like it's hitting twice here, it's hitting twice here. And this one, if you recall, you can't share the x values. This is the x values is first in the mapping and then the y. And so since it's going twice to 0, no go. So the only one is B. Number 5, based on the following 2 functions, which statement is correct? So we have a function in a table, and then we have an equation. So you're going to have to glance at the choices. They're talking about the rate of change. So rate of change, don't forget rate of change is your slope. Is the slope. Fancy words for slope. Remember, or your m. Okay. So let's go back to here and take a look. Can we determine a rate of change here? We want to look at the change in y or the change in x. So we notice this went plus 2 to get to 3, plus 1 to get to 4, plus 2 to get to, okay, so we're kind of consistent. Now let's see what happens here. For between the 5 to 13 was plus 8, 13 to 17 is plus 4, and 17 to 25 is plus 8. So let's think about this. Change in y over change in x. If you took 8 divided by 2, 4. 4 divided by 1, 4. 8 divided by 2, 4. So the rate of change for this table is by 4. And what's this one? By 4. So, letter C. The rates of change are equal for both functions. Okay, this one's a short answer, which you have to do some writing. Okay. Answer the following questions completely, show all your work, and remember to label your answers. All right, so let's look. Use the graph. Describe the speed of the car over time. So study the graph a minute. Car speed started out, it looks like maybe 46 miles per hour. And on the bottom, so the speed is at 46 miles per hour, but they're timing the trip in seconds. So the car started 46, but by the 5th second of the trip, it had slowed down to probably 24-ish. And then it went at a constant rate of speed over time at 24 miles per hour until the 10th second mark. At 10 seconds, it did what? It started to slow down again until the 15th second mark. So it decreased from speed, let's say 24 to 0, to stopping. How would you write this? The car's initial speed is about 46 miles per hour. The next 5 seconds, the car slows down to about 24 miles per hour. The car, for the next 5 seconds, stays at 24 miles per hour, a rate. Then, at 10 seconds, the car gradually slows down at a constant rate until it stops at 15 seconds. Okay? All right. Number 7. For each of the equations below, find your slopes and y-intercept. This one should be easy. Remember, we're looking at y equals mx plus b. So m is 3/4 is your slope, and your y-intercept is -6. This one has to be kind of flip-flopped a little bit. Your slope is the -2, and your y-intercept is 7. As simple as that. Okay, given the following relationships, state the domain and the range for the relationship. Remember, domain is the x values and the range are the y values. You just don't repeat them when you list them out. So this is so simple. Domain, take the x values and write them down. Oh, the last 2 were repeated, but only put 8 once. Then do the range. So what numbers were part of the set of y values, let's say. Okay? Did not repeat the 8. Don't put 8, 8. All right? Professor Octavius said the relation above is a function. Explain why Professor Octavius is correct or incorrect. The professor is incorrect. Okay? The domain has the value of 8 twice. Okay? It is mapped to 2 different range values, causing it to not be a function. That's as simple as that one is. This could be a very typical question. Number 5. What is the slope and the y-intercept for this line? Okay, y-intercept is easy. Where is it crossing? At -5. 0 and -5. How do I determine my slope? I just make my little set of stairs, my rise and run. The line is going in a downhill way. Remember, we looking at it left to right. This is downhill, so therefore it is negative. And what is it? Rise over run is by 1. So slope's -1. The equation, put it all together. Y equals -x minus 5. Okay, this one's a little bit more challenging, only because when you look at the graph, the boxes are not by 1. The x-axis is counting by 2s, right? So every box has a value of 2 going left, but the y-axis is counting by 3s. So totally set you up to be tricked on that one. Okay, easy enough. The y-intercept is 0, 3. The slope, the rise, remember rise over run. The rise over the run, the rise is actually by 3 units, and the run is 2. So that's why it's 3 over 2. And the equation is y equals 3/2 x plus 3. Okay, be careful to notice the width and the height of the graph of the boxes. The x's counted by 2's and the y's counted by 3's. Okay. Complete the table below with the missing values for y. So we knew, you just figure out the pattern. It's going down by 3, so the next one is 2, then -1. On the line below, write the function. There's your b. Remember, whenever the x is 0, what's my slope? This was decreasing by 1, so it's the m. The m here is -3 over 1. So therefore, y equals -3x plus 2. Okay, a line contains these 2 points. What is the equation? Okay, find the m, then the b. So the first thing we're going to do is find the m by going through the formula. Y2 minus y1 over x2 minus x1. Notice it's 5 minus 1 over 4 minus 2, and you get 2. What's your b? Well, once you got the m, you can use whichever point. I used 4, 5, put it in here, and I went 5 is your y equals 2 times 4 plus b, so that makes 8. Bring the 8 over, subtract it, so b is -3. Okay, think about that one. This is 2 steps. This is a good challenging one. Write the equation on the line given a point. If you're just given a point, you can find the slope. Once you find the slope, you can figure out the b. Just plug it in and solve for b. Okay, page 7. Up here, graph the equation. Y equals -3x plus 5. So the m is -3, and the b is +5. So I start at 5, put a nice big dot. My slope is negative, going downhill. Rise over run, -3 over 1. So I'm going to go down 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1, so on. There's your line. Nice and long, not just a little segment, the whole width of the graph. Is 4, -8 a solution to the above equation? So 4 over 4 and down 8, is that on there? It's close, but according to the way my ruler's rolling, it's not. We're going to prove it by putting it in the equation. Y equals -3x plus 5. I know if I plug in, -8 is your y, and your x is 4. So -3 times 4, oops, -3 times 4, I made a mistake here, let's fix that, makes -12. A -12 plus 5 makes, hang on, -7. Makes -7. So therefore, it's not -8. And you could tell the line would be, if it was 4, it would probably be -7. 1, 2, 3, 4, 5, 6, 7. Yeah, it would have been right here. It would have been the next one. 1, 2, 3 over 1. Yep. Okay, so it definitely is not that. Graph this equation. Y equals 2/3 x, where the b is 0, so we're starting here. And we are, I'll do my run first. Run 1, 2, 3, up 2. Run 1, 2, 3, up 2. Done. Nice long graph. Long line. I mean. Aha, so good work. Okay, graph the following equation. 3x minus 2y equals 4. You must put it in y equals mx plus b form first. So I need to rearranged this whole equation, the original equation, so I get y alone. So I brought over the 3x as a negative 3x, so I have negative 2y equals negative 3x plus 4. Next step, divide by negative 2. And when I divide by negative 2 on this side, I get a slope is negative divided by negative makes positive 3/2 x, and this makes minus 2. So this is technically what I have to graph. And the m is 3/2, and the b is negative 2. So I start at negative 2, and I use my slope. Rise over run. Rise 3, 1, 2, 3 over 2. Rise 3, 1, 2, 3 over 2. And there you go. What's the slope and the y-intercept of the graph? Make sure you answer it in the right spot. Okay? Number 16. The cost C of a car wash depends on the time you wash, T. Suppose a car wash costs $1.50 per minute and has an initial charge of $2. Okay, $1.50 per minute, that's your M. That's the per, that's the unit rate. This is your B. Okay, write the function cost, capital C, they told you to use that, and they told you to use T. Cost equals $1.50 times T plus 2. Using the equation, what would it cost for a 14-minute car wash? Put the 14 in there, $1.50 times 14 plus $2 comes out to be 23. Using that equation, how long can you wash your car if you were charged $20? So that's your cost, 20 equals $1.50 times T minus plus 2. So you know you got to pay the 2, so that comes off. So you got $18 is costing for the $1.50 times T, divide by $1.50, and you get 12. So it'd be 12 minutes you can wash your car. Okay, number 9. Again, this is the non-x is 0. You can't have it. It would be undefined, okay? Cannot have x as the denominator. You can't divide by x. It would come out to be undefined. Number 18. The graph shows the amount of water in a bathtub as a function of time. So always take a look and study what is going on here. Draining tub, water's coming out. That's why it's decreasing, therefore negative slope. It's going downhill. What's happening? Looks like the tub had, let's say, 14 gallons of water, and over the next 15, 20 minutes, it was being emptied out. Calculate the rate of change. Okay, so the rate of change from one box to the next. It went down 2, and over, this unit is counting by 3. So the rate of change is minus 2 gallons per 3 minutes. Explain what that rate of change in the y-intercept means. The y-intercept is 14, which means the tub has 14 gallons of water. Then it starts to drain at the rate of 2 gallons every 3 minutes. Okay? 2 gallons every 3 minutes. Alrighty, and that is it. Then the last page is just a practice page. How would you graph these lines? And I just use, basic numbers. You start with the simple numbers and come up with your XY axis. I'll just let it film and you can have a look. And always remember, even if that is this is your B, this is your rate of change. The number in front of the X determines the rate of change or the slope. So this is a positive slope going uphill. This is a positive slope going uphill. This one has really a -1, so it's going downhill. This one will have a positive slope, the 6x going up, negative slope, negative x going down, positive slope going up, a negative slope, therefore going down, right? Going through 0, 0, right? This one, positive slope of 4, so it's going to go up. And the last one, a positive slope of x, crossing at 2, starting at 2, and it's going up by 1, right? So, good practice. This is purely a practice page. Setting up your graphs and hopefully using a ruler, making nice, crisp, straight lines. And this is the end of Unit 4, linear functions.